Okay, so we are recording now, and like I said, we're just going to go through um, basically just the exam 2 answers, and I will be more than happy to also take individual questions from you guys. So if you have any questions as I go along going through this exam, just send me a chat, or since there are so few of you, you can go ahead and just unmute yourself and interrupt me, and I can try to answer as best I can. Okay. So this exam covered material from the second half of chapter 3, chapter 5, and chapter 7. So there was a lot of material that we covered in this section of the class. But hopefully now that we've also gone through and learned about all the different market structures, coming back to some of these ideas and concepts may seem a little bit easier and maybe a little bit more familiar now that we've applied some of them to different market structures. But the first part of this exam covered the remaining section of chapter 3, where we talked about some of the different kind of applications dealing with the supply and demand model. So the first question here says, refer to this figure. At the equilibrium price, the producer surplus is what? So we talked about how the supply and demand diagram can also show these concepts of consumer surplus and producer surplus. So consumer surplus is the extra benefits consumers get when they pay a price that is lower than their willingness to pay. And the consumer surplus is the area under the demand curve and above the price. So in this picture, consumer surplus would just be ABC, the area under the demand curve and above the price. Producer surplus is the extra benefits producers get when they charge a price higher than their marginal cost. So this is the area below the price and above the supply curve. So we see that at the equilibrium price, the producer surplus is just DHF. If this had said consumer surplus, it would be ABC. And if this had said total surplus, it would be ABCDHF. Number 2, another way to think about the demand curve is that it represents the blank of the marginal consumer. So we learned that the demand curve, at each point along this demand curve, it represents the marginal person's willingness to pay for a good, their maximum price that they're willing to pay for a certain good. So people on this part of the demand curve are willing to pay a higher price for this good or service, and people on this part of the demand curve are only willing to pay these lower prices. So the demand curve kind of represents the person's willingness to pay for a good or a service. Number 3, another way to think about the supply curve is that it represents the blank of the marginal producer. So you can think about the supply curve as representing the marginal total cost of producers. So producers on this part of the supply curve, have costs that are much lower compared to producers that are on this part of the supply curve that have costs that are much higher. So producers on this part of the supply curve are going to be the ones producing this good because the price that they're able to charge is higher than what it costs them to make the good. So they're going to be making some profit. These producers up here are not going to be making this good or service because their total costs, their marginal total costs are too high compared to the price that they're willing or able to charge in this supply and demand model. So demand curve, willingness to pay, supply curve, marginal total cost. Okay, so then we also talked about, well, this kind of goes back to the consumer surplus definition that I just gave a couple minutes ago. But this required you to actually like calculate the area of the triangle. So referring to this figure now, at the equilibrium price, consumer surplus is blank. So in this figure, we know that the consumer surplus is the area below the demand curve and above the price. So it would be the area of this triangle right here. So the area of a triangle is 1/2 the base times the height. So if you do 1/2 times the base, which is 30, times the height, 120 minus 60, which is 60. So if you do 1/2 times 30 times 60, you should get an answer of 900. So again, this was not only knowing what area the consumer surplus is on the supply and demand diagram, but you also had to find the area of a triangle. Referring back to this same figure again, the equilibrium allocation of resources is blank. So this goes back to this idea, and we kind of hit on this idea a little bit more in the exam 3 section with all the different market structures. We found and we talked about how in perfect competition, which is what the supply and demand diagram represents and assumes is perfect competition, we learned that perfect competition maximizes the total surplus, or it makes the most number of buyers well off, and it makes the most number of sellers well off when they both agree on the price to charge for a specific good or a service. So at the equilibrium price, this is efficient because total surplus is maximized at the equilibrium. So this was just knowing that total surplus is maximized at this market equilibrium. Okay. So in addition to kind of playing around with what different areas of this model represent and what these, supply and demand curves could also represent, we also talked about how, in addition to the market determining the price for a good or a service, we also talked about, what if the government were to step in and kind of set these, price control laws that will determine the price in a market. And we talked about 2 main price control laws: price ceilings and price floors. Price ceilings, they set the maximum price for a good or a service. So the government will impose a price ceiling if they don't want a good to get too expensive. A price floor, on the other hand, is the minimum price that the government could impose on a market. So the government would want to set a price floor if they don't want a good or a service to get too cheap. An example of a price ceiling is rent control laws. So that's a pretty famous example that's used in econ classes a lot. And a price floor would be the minimum wage. So the government doesn't want labor or your compensation for labor to get too cheap. So the government sets a minimum price that workers will be able to get for their labor. So how do these different price controls kind of interact in our supply and demand diagram? That's kind of what these next few questions hit on. So a binding price floor, and this was just knowing basically what a binding price floor does to a market. So if a minimum price, the price floor, is set above the equilibrium, that will make it a binding price floor. So if the floor is above the equilibrium, that makes it binding. And when there is a price floor set above the equilibrium, this causes a surplus. So essentially, this just means that the quantity supplied of this good or service at this new kind of higher price is going to be greater than the quantity demanded. So a binding price floor causes a surplus and is set at a price above the equilibrium price. A binding price ceiling, on the other hand, kind of does the opposite of a binding price floor. So a binding price ceiling causes a shortage and is set at a price below the equilibrium price. So again, just knowing the difference between price ceiling and price floor and how these price controls interact with our kind of market supply and demand model. Okay, so these actually 8, 9, and I think 10. Yeah, 8, 9, and 10 required you to actually kind of calculate what the size of the shortage or the surplus would be if these different price ceilings and price floors were to be set in this specific market here. So we have supply and demand model here. So if the government imposes a price ceiling of $6 on this market, then there will be what? So we go up to our supply and demand model. We know that at the equilibrium, we can find that the price that buyers are willing to pay for this good and the price that sellers are willing to sell this good at is $4. They have agreed that $4 is a good price for this market. But if the government steps in and says, we're going to impose a price ceiling of $6. So the maximum price that this market is allowed to charge for this good or service is going to be $6. Now, since this is, the maximum ceiling, and buyers and sellers have already agreed that $4 sounds okay, they're not hitting that ceiling. They're not going above the ceiling. So the buyers and sellers are already following the guidelines of this law, so it's not binding. So buyers and sellers are just going to behave the same way that they were before this law was put in place. So if the ceiling is above, then no shortages will happen due to this law. Nothing will change. They set the maximum at 6 and the price was already at 4, so they're not hitting the maximum yet. So no shortage of the good. But what happens if the government imposes a price ceiling that is below the equilibrium? And we learned up here in previous question that a binding price ceiling is going to cause a shortage. So if the government imposes a price ceiling of $2 on this market, so equilibrium, they're happy with $4, but the government says, now the maximum price that you can charge for this good is $2. Well, buyers and sellers were happy with 4, but now they have to kind of change their behavior and abide by this law. So this is a binding price ceiling, and this is going to cause a shortage. How much of a shortage is this going to cause? Well, you just essentially have to see where this new price ceiling intersects both the demand curve and the supply curve. So if we are at this $2 and we walk along, we see, okay, 25 is the quantity that suppliers are willing to supply at this kind of new lower price. They were willing to supply 45, but now that the price is lower, they're not willing to supply as much because they can't make as much in terms of revenue anymore. So now they're only willing to supply 25. However, since the price is now lower than what it used to be, the quantity demanded for this good is actually going to go up compared to what it was in equilibrium. So before, people were demanding 45 of this good or service, but now that the price is lower, the quantity demanded goes up to 55. So people are demanding 55 of this good or service at this new lower price, but sellers are only willing to supply 25 of this good or service. So people want 55, but there are only 25 available. So that's how you get a shortage of 30. You do 55 minus 25, and you get a shortage of 30. And then the last question dealing with that figure, if the government imposes a price floor of $6 on this market, then there will be what? So if we go back up here, we already found from question 8 that a price ceiling of $6 doesn't do anything. But if the floor is above the equilibrium, this is where it changes the behavior of the buyers and sellers. So if this is a price floor at $6, people are going to be demanding 35 of this good or service. But suppliers are willing to supply 65 of this good or service. So at this new kind of inflated price, suppliers are willing to supply a lot more because they think that they can make more revenue from that. However, on the other hand, buyers are not willing to pay this higher price. So people are only demanding 35, but suppliers are making 65. So there's 65 units available, but people only want 35 of them. So there's going to be a surplus of 30 units. So there are going to be 30 extra units just laying around that no one wants to buy at this new higher price. Okay, so that was basically all of the stuff dealing with the end of chapter 3. Now we'll move into the chapter 5 stuff, which is dealing with the concept of elasticity. Number 11, the demand for a good is considered more elastic if the good is a luxury. So remember, elasticity kind of deals with, or an easy way to think about elasticity is kind of like a buyer's responsiveness to a change in the price. So if a consumer is more elastic, that means they can be kind of more flexible or more responsive if there are small changes in the price for a specific good or a service. So if the demand is more elastic, this means that consumers are more flexible when it comes to these different price changes. And consumers are pretty flexible when it comes to luxuries. So if the price of a luxury changes just a little bit, that will probably deter a lot of people from not buying it anymore. Versus if it was a necessity, then a price change may not deter a lot of people from buying that good. So it really, is how flexible people can be in choosing to buy this good if the price changes. And I kind of outlined so what makes demand more elastic? Close substitutes, narrowly defined luxuries, and long run. So those, if you need more details about what these mean, I think I have like a little chart in the lecture notes that I also put together as well. Okay. When the change in the quantity supplied is greater than the change in the price, we can say that supply is relatively what? So if the change in the quantity is bigger than the change in the price, if we use this little ratio that we use to represent elasticity, the numerator is going to be bigger than the denominator. So this means that this elasticity ratio is going to be bigger than 1. So if the elasticity is bigger than 1, we can say that this good or service is more elastic. So more elastic, and that also means more responsive to price changes. So that's why both B and C are correct. So if quantity supplied is bigger than the change in the price, this means more elastic based on this little formula here. When demand is inelastic, so inelastic is the opposite of elastic. So elastic, people can be really flexible and change their behavior, not buy as much if the price goes up. Inelastic, people are kind of stuck, or they can't be as flexible if there are price changes. So correct answer here, when demand is inelastic, consumers are not very responsive to changes in the price. So again, that's just knowing the definition of inelastic. Okay, number 14, consider the demand and supply for life-saving medicine. If the demand curve for a life-saving medicine is perfectly inelastic, then a decrease in supply will cause the equilibrium price to what? Okay, so there are a lot of parts to this question, so let's go back to this first part here. If the demand curve for a life-saving medicine is perfectly inelastic, what does that demand curve look like? Well, I think I have... Maybe I don't have it exactly here, which is weird. Anyway, so if a demand curve is perfectly inelastic, that means no matter what the price is on the vertical axis, the quantity that someone is going to be demanding doesn't really change, which kind of goes back to the definition of inelastic. So people can't be flexible when the price changes. So we represent that with a perfectly vertical line for the demand curve. So a perfectly inelastic demand curve is straight up and down. So if we have a demand curve that's perfectly straight up and down, and then we have kind of just a regular unit elastic supply curve, if there is a decrease in supply, so I don't know if I can kind of represent this here. So here's demand and here's supply. If there's a decrease in supply, that means supply is going to shift to the left. So the quantity didn't change from this equilibrium to this equilibrium, but the price went up. So if there's a decrease in supply, this will cause the equilibrium price to go up, and the equilibrium quantity is going to stay exactly the same because people can't change their behavior really because this life-saving medicine has perfectly inelastic qualities associated with it. Okay, number 15. Let's just say on a certain supply curve, one point is quantity supplied equals 200, price equals $2. And another point is quantity supplied equals 250 and price is $2.50. So using the midpoint method, the price elasticity of supply is about what? So this was just knowing how to use this formula here that I included on the test. If this question is put on the final exam, I will also include the formula for you guys. But essentially, it's just taking this change in the quantity divided by the change in the price and making it just adding one more little step to that formula. So we still have the change in the quantity over the change in the price, but we're going to divide both the numerator and the denominator by the midpoint in between those 2 points. And I don't know if you guys remember, but I have a little discussion in the lecture notes that kind of explains, why we did that. And the reason we did that is because if you choose a different point as your starting point, and you just do a simple percent change formula, you'll get different answers. But if you use the midpoint, you won't get different answers. So you can choose either point as like your 0.1 and 0.2. It doesn't really matter if you use this midpoint method. So basically you just have to plug in all of the numbers into this formula. So let's just assume this point right here is 0.2 and this point right here is 0.1. So quantity 2 is 250, quantity 1 is 200. So then you divide this subtraction by the midpoint between those two. So if you do 250 plus 200 divided by 2, you should get the midpoint between 200 and 250, which is 225. So if you do 250 minus 200 divided by 225, that will be your numerator. And then you do the same thing for the price. If you do $2.50 minus $2 divided by the midpoint between those two, which is $2.25, you'll get your denominator. And then you just divide the numerator by the denominator, and you should get 1, because these are essentially changing by the same amount. So this supply curve, we can call it unit elastic. Okay. Okay. Number 16, if after using the midpoint method to calculate the price elasticity of demand, you get an answer of 0.59 as your final answer, what can you say about the relative price elasticity of demand for this good? So if you went through this calculation here, and your final answer wasn't 1, but it was, let's just say, 0.59, we can go back here and say that if, when you calculate elasticity, and it's less than 1, we can say that this good or service is relatively inelastic. So basically that means that the change in the price was greater than the change in the quantity. So with this, if there's a really huge price change, the quantity couldn't change that much. So that would make it inelastic. Uh, 17, blank is the change in what is on the horizontal axis divided by the change in what is on the vertical axis. So again, this is just another way to say the definition of elasticity. 18, youth smoking seems to me more blank than adult smoking. That is, the quantity of youth smoking will fall by a greater percentage than the quantity of adult smoking in response to a given percentage increase in the price. So I remember I had quite a few people come into my office hours to talk to me about this question because it was a little bit confusing. But essentially what is happening here is we just kind of have to go back to this little formula. So if we have kind of like the demand for youth smoking and the demand for adult smoking, we can kind of analyze these two different groups separately and then compare what their elasticities are. So we know from this question that the quantity of youth smoking will fall by a greater percentage than the quantity of adult smoking. So let's just say if there is this price change, so let's say the price of cigarettes goes up by, I don't know how much cigarettes are. If it goes up by a lot, the quantity change for youth smoking is going to change a lot compared to the quantity change for adult smoking. So if this denominator is the same for both young people and older people, and the numerator is much, much bigger for younger people compared to older people, we can say that this ratio is probably going to be bigger than 1 for younger people and maybe less than 1 for older people. So youth smoking seems to be more elastic compared to adult smoking, which is more inelastic. And I guess kind of like the rationale you can think about that is maybe for older people who have been smoking for a long time, cigarettes have almost become a necessity if they have become addicted. So they can't be as flexible with given price changes if they, you know, need a certain quantity of cigarettes. So just another way to think about it, but youth smoking seems to be more elastic than adult smoking is kind of like the bottom line of that question. 19, the longer the time period considered, the more the blank or the more the elasticity of demand tends to what? So what makes demand more elastic? Close substitutes, narrowly defined luxuries, and the long run. So as more time passes, people can be more flexible about the quantity of a certain good that they buy. So the longer the time period, the more the elasticity increases. Economists can represent a relatively elastic demand or supply curve by drawing the curve relatively flat or completely horizontal if it's perfectly elastic. So remember, elastic is perfectly flat, inelastic is perfectly vertical, and then everything else kind of falls in between those two extremes. Okay, and then the last section of the test covers chapter 7, where we started introducing all of the different kind of cost curves and the production function and things like that, where we kind of diving into the supply side of things. And we went into more detail about all the different types of firms in the 3rd section of the class when we talked about the competition spectrum. But this stuff kind of introduced you guys to like total cost, fixed cost, variable cost, and all these other different definitions and stuff. So 21, the difference between accounting profit and economic profit is implicit cost. So if you were to kind of sit in an accounting class, you would find that accounting profit is just total revenue minus your explicit costs. But economists also include implicit costs in terms of, you know, this cost side of things. So it's not only the explicit cost that someone pays their workers or pays for their equipment or pays rent for their, you know, factory or whatever. It's also the implicit cost or the opportunity cost that that firm owner could be facing. So one way to think about this is the implicit cost of running a certain business is money you could be making from, you know, doing something else. So economists like to also consider that implicit cost when we talk about economic profit. So implicit cost isn't included in accounting profit. So that's the key difference between the two. Which of the following is not true about production functions generally? So I have listed here, we briefly talked about production functions. We didn't really use them too much more in the rest of the class. But I have everything listed, the characteristics of production functions. Production function is basically how much a company is able to produce given certain inputs they have. So it's kind of like they have inputs, what is their output? And kind of like that connection is the production function. So the production function includes both fixed and variable inputs, and the slope of the production function is the marginal product of labor. So here for this specific question, which of the following is not true? The functional form of a production function includes only fixed inputs. And we found from the study guide that it includes both fixed and variable inputs. And all of these others are true based on this little blurb here on the study guide. Okay, 23. What is unique about costs in the long run compared to the short run? So I believe I also have that listed here. In the short run, inputs and costs can be fixed or variable, but in the long run, inputs and costs become variable. So essentially, kind of like the rationale behind this is in a, in the short term, everything isn't up to the firm to change. So they can't really change the size of their factory in the short amount of time if they sign like a 12-month lease. They can't really change, the amount of equipment they have if it takes a long time, to ship the equipment to them or whatever. So in the short term, some stuff is kind of like a fixed cost to the firm. But if enough time passes, everything kind of becomes variable. The firm is allowed to kind of change up how big their factory is or how many workers are hired, etc. So in the long run, all costs are variable, while costs could be both fixed and variable in the short term. Okay, 24. So this kind of goes back to that little chart that I gave you guys some practice with in class and in the problem set. I still have that example in the lecture notes if you want to practice again working with this chart. But essentially, what you have to do is kind of know some of these key kind of little equations, and that will help you kind of fill out the empty spots in these charts, if that's the goal of the question. You should know that total cost is equal to fixed cost plus variable cost. Anytime you need to take the average, whatever cost, it's just, so for example, here I have average total cost is just total cost divided by quantity. And then the marginal cost, which is the one that is a little bit different from the others, is that this is the change in total cost given a change in quantity. So knowing all these little kind of equations, we can attempt to start filling out this chart here. So the question is kind of asking for square A and square E. So if we look down here, we can see that square A is the variable cost associated with a quantity of 3. So I think the easiest way to figure out what this square is just know that the fixed cost is going to be constant no matter what the quantity is. So this 30 can kind of be filled into all of these empty squares here. So the fixed cost for 1 is going to be 30, 2 is going to be 30, 3 is going to be 30. And if we know the total cost is 72 and the fixed cost is 30, then we know the variable cost has to be 42 because A plus 30 has to equal 72. So if you do 72 minus 30, you should get 42. So we know that it's either A or B at this point. And then square E is looking for the marginal cost. So the marginal cost, again, is the change in the total cost given a change in quantity. So at this point, we kind of need to know what square B is to figure out what the change in total cost is. But that's pretty easy to figure out because we know the variable cost for a quantity of 1 is 12. Fixed cost, again, is 30. So we know the total cost here is 42. So if we go from 0 to 1, the total cost changes from 30 to 42. So that would mean the marginal cost is just 12. So the change here is 12, and the change here is 1. 12 divided by 1 is 12. So that's why that's B. And then referring to the table above, square D here is equal to what? Well, this one's pretty easy too, because we know that average variable cost is just going to be variable cost divided by quantity. So if we do 25 divided by 2, we should get 12.5 for square D. Okay, we're almost finished. Blank is calculated by taking the quantity of everything sold and multiplying it by the sale price. So this is just total revenue. So again, total revenue is the amount of money that a firm brings in from selling a certain amount of goods or services. And to calculate that, you just do the quantity of stuff that they sell times the price that they charge for it. And that will tell you how much money the firm is bringing in. Okay, 27 and 28 deal with this table here. If a firm produces 5 units and sells at a price of 30, what will its profits or losses be? So again, this just goes back to our little profit equation. Profits equal total revenue minus total cost. So in this chart here, it doesn't straight up give us total revenue, but it does give us total cost. And we just learned from the previous question that total revenue is calculated by taking the quantity and multiplying it by the price. So if the firm sells 5 units at a price of 30, we know that the total revenue, therefore, will be 5 times 30, which is 150 total revenue. And then we just do total cost for 5 units, which is 155. So the firm is bringing in $150, but it's costing them $155 to make this amount of this good. So they're going to be losing $5. And then we just basically kind of do the same exact thing, but instead of looking at 5 units, now we're looking at 3 units. So if the firm is producing 3 units and sells them at a price of $30 each, 3 times 30 is 90 total revenue. Total cost is 100. So 90 minus 100 gives us negative 10, which would be losses equal to 10. And then 29, total cost equals fixed plus variable cost. So again, it's just knowing this little kind of equation dealing with total cost. And then 30 asks you which of the following curves generally has a U shape attached to it. So at the very end of this chapter, in the lecture notes, I went through all the different shapes that these curves have, and I also summarized it here. So you can see that the average total cost and the average variable cost are the ones that are U-shaped. So that's why the correct answer here is average variable cost. Okay, we did it. So that was exam 2. And like I said, it kind of covered a wide range of different topics. But hopefully going through this was relatively helpful to kind of, jog your memory about these different topics that we covered. Do you guys have any questions about anything? I still have a couple minutes. I'll be happy to answer any questions you have. Okay, great. So again, hopefully this was helpful. I recorded this video and I'll also post it to the YouTube channel later today for you guys to watch before the final. So thank you guys for coming and have a good rest of your week. And maybe I'll see you on Friday for Friday's review session.